Filmmaking started at the development of conventional photography by capturing light with grains or crystals of silver. Eventually it was discovered that bigger crystals capture more photons of light, and people researched on means to make the grains of silver more efficient to capture light. One of the first film cameras for film designed by Edison was called Kintograph. It became very popular during the silent era. The cameras evolved from the first versions of 16 frames per second to 24 frames per second. That speed has been in use for 100 years. The invention of the celluloid is another technology that facilitated filmmaking, created by George Eastman, founder of Eastman Kodak. This film material was based in cellulose nitrate. It had sprocket holes down each side to advance the film in the camera, and its width was 35 millimeters. During the black and white era, the films were more sensitive to blue and violet light, orthochromatic, so the costume and set designers had to adjust their products to this limitation. In 1921, Kodak invented chromatic film that was sensitive to all the colors of the spectrum, that allowed to have rich variations of whites and blacks. By 1932, the Technicolor company developed a color system using 3 strips of film running through the camera based in 3 primary colors: red, blue and green. By this process required expensive cameras and 3 times more film than usual. But Eastman Kodak with the Eastman color system replaced this film, in the 1950s, with a film of 3 layers, each one sensitive to one of the 3 primary colors. It has been improvement also in the editing process. Originally the films were short and required simple process of cutting. But as the films became longer and complex, it was necessary to create mechanical devices to edit the film in post-production. Then the Mode Viola editing device became the standard, with some upgrades until 1970s, when the videotape technology and computers arrived. These technologies allowed film editing faster and more precise. In 1856, Oskar Rolander created the world's first trick photograph by combining different regions of 32 other photographs into a single image. In 1895, Alfred Clark created what is commonly accepted as the first ever motion picture special effect. While filming the reenactment of the beheading of Mary, Queen of Scots, Clark instructed an actor to step up to the block in Mary's costume. As the executioner brought the axe above his head, Clark stopped the camera, had the entire actors freeze, and had the person playing Mary step off the set. He placed the Mary dummy in the actor's place, restarted filming, and allowed the executioner to bring the axe down, severing the dummy's head. Such techniques would remain at the heart of special effects production for the next century. This was not only the first use of trickery in the cinema, it was the first type of photographic trickery only possible in a motion picture, i.e. the stop trick. In 1896, French magician Georges Méliès accidentally discovered the same stop trick. According to Méliès, his camera jammed while filming a street scene in Paris. When he screened the film, he found that the stop trick had caused a truck to turn into a hearse, pedestrians to change direction, and men turn into women. Méliès, the stage manager at the theater Robert Houdin, was inspired to develop a series of more than 500 short films, Between 1914, in the process developing or inventing such techniques as multiple exposures, time-lapse photography, dissolves, and hand-painted color. Because of his ability to seemingly manipulate and transform reality with the cinematograph, the prolific Méliès is sometimes referred to as the ciné magician. His most famous film, Le Voyage on la Lune, a whimsical parody of Jules Verne's From the Earth to the Moon, featured the combination of live action and animation, and also incorporated extensive miniature and matte painting work. During the 1920s and 1930s, special effects techniques were improved and refined by the motion picture industry. Many techniques, such as the Schouten process, were modifications of illusions from the theater, such as Pepper's Ghost, and still photography, such as double exposure and matte compositing. Rear projection was a refinement of the use of painted backgrounds in the theater, only substituting moving pictures to create moving backgrounds. Live casting of faces was imported from traditional mask making. Fantastic masks could be created which fit the actor perfectly. As material science advanced, horror film mask making followed closely. Through the 1950s and 60s, numerous new special effects were developed which would dramatically increase the level of realism achievable in science fiction films. The pioneering work of directors such as Pavel Glushantsev would be used by major motion pictures for decades to come. If one film could be said to have established a new high benchmark for special effects, it would be 1968's 2001, A Space Odyssey, directed by Stanley Kubrick, who assembled his own effects team, Douglas Trumbull, Tom Howard, Con Pedersen, and Wally Weavers, rather than use an in-house effects unit. In this film, the spaceship miniatures were highly detailed and carefully photographed for a realistic depth of field. The shots of spaceships were combined through hand-drawn rotoscopes and careful motion control work, ensuring that the elements were precisely combined in the camera. A surprising throwback to the silent era, but with spectacular results. Backgrounds of the African vistas in the Dawn of Man sequence were combined with soundstage photography via the then new front projection technique. Scenes set in zero-gravity environments were staged with hidden wires, mirror shots, and large-scale rotating sets. By the end of the 70s, a new change of filmmaking was precipitated by the blockbuster success of two science fiction and fantasy films in 1977, Star Wars and Close Encounters of the Third Kind. The first one, created by George Lucas and John Dykstra, developed many improvements in existing effects technology. They developed a computer-controlled camera rig called the Dykstra Flex that allowed precise repeatability of camera motion, greatly facilitating traveling matte compositing.
The thing about visual effects is when I did Star Wars, I had an idea of doing this crazy 1930s serial action-adventure film, and the idea was it would be very, very fast-paced and very exciting. The problem was there really were no special effects facilities at that time. Doug Trumbull had the closest thing to a special effects facility, but he was trying to be a director and direct features, and he'd retired from the special effects business at that point. So I went to a few of the people that worked for him that were doing sort of industrial films for the planetariums, or people that were doing Pillsbury Doughboy commercials and that sort of thing, and then a lot of college kids, because they're just, apart from an occasional map painter at Disney or doing Bond films, there really wasn't any industry. None of the studios had special effects departments anymore. They'd all been abandoned. So I was sort of forced to start my own company in order to make the movie. And that's really how ILM got started in the first place. And I knew that I wanted something that was going to sort of, I had to push the limits of the technology of the film medium in order to make this movie work. Because I couldn't have just spaceships slowly moving through the frame. I wanted to be able to pan with them, move with them.
The second movie, directed by Steven Spielberg, boasted a finale with impressive special effects by 2001 veteran Douglas Trumbull. In addition to developing his own motion control system, Trumbull also developed techniques for creating intentional lens flare, the shapes created by light reflecting in camera lenses to provide the film's undefinable shapes of flying saucers.
I mean, it all begins with seeing a picture in your mind and wanting that picture exactly up on the screen, and how to do it. In some cases, I knew how to do it and did it, and did it myself. Other cases, I had no idea how to do it. So I was dependent on the technology, the motion control system, the tank of water, to get these effects and make them real. I can't tell you how many times on a major effect, with let's say the mothership or any of the small objects, we went back for 10 or 15 different takes because none of them were right. Sometimes the ship would bobble, there'd be a mistake, and half the guys would say, the audience won't see that. And I said, I'll see it. I want to see my movie again once it's out. If I see a mistake like that, I'll stop going to my movies.
In 1975, he directed Jaws. In 1978, he directed Close Encounters of the Third Kind. In 1981, he directed Raiders of the Lost Ark. And now, Steven Spielberg brings us E.T., the Extraterrestrial.
I looked at the sequence, and they had a bunch of storyboards for the sequence, so each of us got a rough idea of what these things had to do, how we had to build the scale on the bikes, how we had to scale up the puppets. They were fairly large for animation puppets. I think the tallest one was probably 2 feet tall, which is quite big. Ordinarily, you work on a scale of about, 8 or 10 inches. It's just easier to work that way. Easier as an animator to work that way. But these were built large so that we could get the detail into the bikes, so that we could get the detail into the outfits that the kids had to wear, which were made out of actual clothing, so that all this would scale up appropriately.
Recent and profound innovation in special effects has been the development of computer-generated imagery, or CGI, which has changed nearly every aspect of motion picture special effects. Digital compositing allows far more control and creative freedom than optical compositing, and does not degrade the image like analog, optical processes. Digital imagery has enabled technicians to create detailed models, matte paintings, and even fully realized characters with the malleability of computer software.
About 1980, I started a computer division, and one of the mandates they'd had was to develop a really good special purpose computer for computer graphics, and started working on that over the years and trying to develop it, and as we went along, and then we finally got to Jurassic Park, and so when I went to say I'm going to do a Star Wars film, I realized that it would be much better for me to actually capture the material in a digital medium, and because it all had to be put into a digital medium in order to work with it in these computers that we developed at ILM. So I knew the whole film was going to be in a computer at some point, and I knew that if I captured it that way and put it in that way, it would be much less cumbersome, because it's very hard to transfer from one medium to another medium. And that's what really got me interested in trying to shoot a film digitally. We started working with Sony to develop these cameras and try to get them to develop in 24 frame and make them compatible with what we were doing with ILM. And we managed to get Sony, they had a camera, and we finally got them to say, okay, we'll build this as an actual production camera. Then we had to find somebody who would build a lens that would go on the camera, and that took a while because nobody wanted to build lenses for this thing. But that meant that I knew now that I had the cameras, I had the lenses, and I could shoot the next film completely digitally, and I wouldn't have to move back and forth between mediums, which was very important, because digital is I felt at that point the quality was close enough to film that I wasn't going to end up with any less of an image. But the process itself is so much more malleable, so much easier to use, so much less restrictive, that it would give me a huge advantage in terms of the actual day-to-day process of making the movie. And it would save me a lot of money. I'm still, an independent filmmaker. I still pay for all my own bills, and I really have to be careful. I don't have the unlimited resources of the giant mega studios. I still have to sort of worry about where I'm going to get the money for my next film if the one I'm working on either goes over budget or doesn't do as well as I'd hoped. So that's always a factor. We're always trying to do it as the least expensive way possible. And digital really made a huge difference there. And then at the same time, I was able to transfer it into the computers, work with it, and then ideally show it digitally. The great thing about digital is what goes in the first day is the same thing you see on the 10th week. Whereas film, what you see on the first day is not at all what you're going to see in the 10th week. In the 10th week, it's going to be scratched and jittery and torn up, and the quality is going to be disintegrated to a rather alarming degree, which is what THX does, is try to keep that from happening, but inevitably there's nothing you can do about it. But with digital, the quality stays consistent through the whole thing. You don't get jiggle in the gate and the image sort of shaking around. You don't get the scratches and all those other annoying things that probably concerns filmmakers more than anybody else, but I do think it has a profound influence on the audience's enjoyment of the movie.
Desktop filmmaking has started to grow. Nowadays, all the people need is a desktop computer, a camcorder, and enough creativity. Now the speculation is how Hollywood will respond to these trends. Observers are divided on whether the new technology will open up Hollywood to new ideas and wider range of new voices. Some of the opinions is that this new technologies have more film industry looks, still the quality is behind of the professional level. The movie industry is responding to the new trends of technology. One of the next advances in Hollywood has to do with the production of movies in 3D. Some film directors are exploring the field, and one of them is James Cameron, who created Avatar, his latest production, using 3D technology.
It's been about 5 years now that he explained to me that he wanted to build a holy grail type camera that can shoot 3D and 2D.
Vince Pace is the director of photography. His approach has been to design a dual camera system that mimics human sight as closely as possible.
And I think that's what separates our approach from standard or old-time film methods, is we are really creating a human machine.
The old 3D filmmakers had two cameras set widely apart. Vince brought the lenses together so their centers were about the same distance apart as our eyes. But to do that, he had to separate the lenses from their high-definition video recorder backs. Impossible to do with film cameras.
So essentially, these are the eyes and the brain somewhere out the back.
Yes, exactly.
Next step in the 3D riddle is to make the cameras act like eyes, able to focus on different subjects at different distances.
Interactive cinema is here, and it's blurring the boundary between audience and screen that has stood firm since cinema's dawning more than a century ago. This new cinema form is being pioneered with T-Visionarium, a technology created by the iCinema Research Centre at the University of New South Wales in Sydney, Australia. To create this experience, artists, designers and engineers have assembled the world's most futuristic cinema, known as the Advanced Visualisation and Interaction Environment, or AVI.
AVI is a 360-degree, three-dimensional projection room, which can take comfortably about 30 people. It allows people to wander at will through the area without having to sit in a fixed location as you would do in a normal cinema.
The experience begins as viewers wearing special glasses stand inside a huge cylindrical cinema theatre. 12 overhead digital projectors create high-resolution stereoscopic images around the 360-degree screen, while audio is delivered through a 24-channel surround sound system. iCinema researchers captured 28 hours of free-to-air Australian television and turned the footage into a visual database containing over 20,000 video clips. Each clip was then tagged with numerous descriptors known as metadata. It means that each video clip is searchable on hundreds of different key search words.
Having the video data segmented in this way deconstructs the original linear narrative into components, short blocks of conversation, short events in circumstances. So you end up with what I call the building blocks, narrative building blocks, little components, which then could be reassembled with other components.
Inside the cinema, the viewer uses an on-screen menu, much like a Google search engine, to select keywords. TVisionarium responds by displaying up to 300 videos from its rich database that float through the three-dimensional space.
Television is no longer something that they passively have to consume, but rather television is just a place where viewers can be editors and directors themselves.
TVisionarium combines the power of cinema and computer technology in an interactive, three-dimensional virtual space.